Hello friends, in this video I will explain Hamming distance and Hamming code. Hamming distance is actually used to represent difference between two equal length binary string, and Hamming code is used for error correction when receiver receive a data. So receiver with the help of Hamming code will identify if there is any correction in the received data or not. So we will see how it works in this slide. So first of all we will see what is Hamming distance. So if we are having two equal length binary string, so Hamming distance will actually show how many bits are different in these two binary string. So if we look at these two string, first bits are same, second also same, third same, fourth different, fifth and sixth are same. So only difference is in one bit. So Hamming distance for these two string will be 1. So formula you can use to calculate Hamming distance: number of positions of different bit. Let's take one more example. So if we look at this example, third bit is different, fourth is also different, and then seventh and eighth. So total number of bits which are different in these two string: 1, 2, 3, 4. So Hamming distance for this data will be 4. Let's see now Hamming code. When receiver receive a data, how receiver going to identify whether the received data is correct or not? So in order to provide this information, some extra bits are added to the data, and those bits are known as parity bits. So in Hamming code, let's assume the sender wants to send this data. This data has to be sent. So data before sending, parity bits are added with this data. Now the question is where parity bits will be added. So in Hamming code, parity bits actually will be inserted at these locations, like 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4 and so on. So if we calculate these locations, it will be first, second, fourth, 8, 16, 32. So these are the location at which we insert parity bits, and remaining positions we will insert our data bits. So remaining positions are 3, 5, 6, 7, 9 and so on. So our data actually going to be inserted at these locations, and 1 to 4 will be having parity bits. So here we are having our data, and these are the numbers showing the position. So parity bits will be added at 1, 2, 4, 8, 16, 32 and so on. And at remaining position data will be inserted. So we will insert our data at remaining position. So this data, first bit inserted at position 3, second bit inserted at 5, third inserted at 6, fourth inserted at 9 and so on. Now question is that how the parity bits will be calculated. So first parity bit, which is 2 to the power 0 location position. So the formula to calculate this bit is check one bit, skip one bit. So what is that rule? In order to calculate parity, we need some bits. So in this string, which bits we are going to consider? So this is the formula: check one bit, skip one bit, and this formula actually applied from the parity bits position. So we will consider a bit at location 1, then we will skip second, we will consider third, we will skip fourth, we will consider fifth, we will skip sixth. So these are the bits which are going to be considered in calculation of parity bit. So here we are considering even parity, In even parity, number of ones will need to be even. So here if we count ones, 1 2 3 4 5, so number of ones 5, and this is not a even number, so in order to make it even we need one more 1, so this parity will be 1. So first parity bit is calculated. Now we are having second. How second parity bit will be calculated? So the formula for second bit is check 2 bit, skip 2, check 2, skip 2. So these bits we are going to consider for calculation of second parity: 2 3 6 7 10 11 and so on. So 2 3 6 7 10 11, and we are skipping 2, 4 5 skipped, 8 9 skipped. So if we count number of ones, 1 2 3 4, so number of ones already even, so in that case here we will put 0. Now we will see how parity for position 4 will be calculated. So for 4, which is location to the power 2, so for this parity we will consider 4 bits, skip 4 bits, then again consider 4 bits. So this rule actually applied from the position of parity. So this rule applied from here. So we will consider 4 bit, 4 5 6 7, then we will skip 8 9 10 11. Again we will consider 12 13 14, and we are not having any bits here, so we will process only till here. So these are the bits which are going to be considered in calculation of parity for fourth position. So if we count number of 1 1 2, so number of ones are already even number, so in that case this bit also will be 0. So now we are left with last parity, which is to the power 3 location. So for calculation of this parity we will consider 8 bits, then we will skip 8 bits, consider 8 bits again. So these are the bits which are going to be considered for this parity. We will count number of ones, 1 2 3 4. So already this number is even, so that's why this parity will be 0. So when receiver receives this data, receiver also applies same rule, and receiver also calculate parity for first, second, fourth, eighth location. Now receiver compare calculated parity with received parity. If those two are matched, data will be considered not corrupted. But in case if those parity not matched, it means data is corrupted, and in that case receiver try to correct the data with the help of having code. Thank you very much for watching.